Again, welcome to our review of basic algebra. In this objective, we are going to study about factoring trinomials. Trinomials means a polynomial with 3 terms. So we're going to learn how to factorize trinomial. And also factorize trinomial by grouping, and also factor the sum and difference of 2 cubes. This is a special formula we use. And also examples of factoring different types of polynomials. So factor trinomial, we have a factorial trinomial squares. Here we have a perfect, normally we call this term as a perfect square. So when I have x squared plus 2xy plus y squared is the same as saying x plus y times x plus y, which is x plus y squared. Now, x plus y squared is meaning we are multiplying x plus y twice, which is this term right here. Now, if I multiply each of these terms by each other, which means we have 2 binomial here, our result will be x squared plus 2xy plus y squared. So let's try it. X times x will give me x squared. X times y will give me xy. Y times x also will give me xy. So we are going to have 2xy. So that's why we have 2xy, xy plus xy. Then the last term will be y times y, which will give me y squared. The same thing also applies to minus. So if I have x minus y all square, is the same as saying x minus y times x minus y, because it's square. So it will multiply itself. Now, if I multiply x minus y by x minus y, I will get x squared minus 2xy plus y squared. So again, our question here is, for example, we have a question which saying that factorize x squared plus 2xy plus y squared. Then the answer will be x plus y times x plus y, or x plus y squared. So this is the strategy for factoring a general trinomial with integer coefficient. So this means first thing we should do, write the trinomial in descending powers of one variable. What we mean is, we can see from here, I have x squared. So if there's another term, x cubed will come first before x squared. So descending powers of one variable. So x cubed plus x squared plus x, decreasing the power. So after we write down the trinomial in terms of descending, the position of each term will be based on the power, descending powers of the variable. The next thing we can do is to factorize any GCF. We did this already. Find the greatest common factor among all the 3 terms. Now, if the first term is negative, then just factorize -1. So we want to make sure the first term is positive. Again, we're going to see an example soon. Now, when the sign of the first term of a trinomial is positive, then that's good. We leave it. And the sign of the third is positive also. Now, the sign between the terms of each binomial factor is the same as the sign of the middle term of the trinomial. We're going to discuss. What we mean is that if the first term is positive and the last term also is positive, automatically the middle term also will be. So when the sign of a first term is positive and the sign of the third term is negative, then one of the signs between the terms of the binomial factor is positive and the other will be negative. So now the last option, we should try various combinations of the first term and last term until you find one that works. If no possibility works, then trinomial is prime. The goal here is, if I have a trinomial, if the coefficient of the first term is 1, I will factorize the x. Let's say we have x squared, so we have 1x and then second x. Now, we find 2 values that when we multiply, we will get the third term. When we combine, we get the second term. And that will be the factor. But again, we're going to do an example. The best way of explaining this is by doing an example. So this is a very nice example we have here. So we have 10xy plus 24y squared minus 6x squared. Remember, the first thing they tell us, we should write our term. If all the terms are the same, write it based on the power. The highest exponent will come first. But here you can see that we have xy, y squared, x squared. So the terms are not the same. So the first thing we're going to do is to see if we can factorize something here. And by looking at it, I think we can factorize 2. 2 can go into 10, 24, and 6. Here we have x is okay, but 24y squared, x is not common. So the only thing we can factorize is 2. Again, the highest exponent is x squared. So we decided to write negative 6x squared plus 10xy plus 24y squared. Again, nothing changes here, just changing the position of the term. So we find that negative 2 is common, so we take negative 2. Why are we taking negative 2? Remember the strategy they gave us. Now our first term now becomes negative 6x squared. So we want to make sure our first term is positive value. So we take negative out so that we can change the sign here. So this means x squared become positive, xy become negative, y squared also negative. So that's what we have here. Again, please follow my, if you are going through this video, follow my cursor points. So here we have negative 2, 3x squared minus 5xy minus 12y squared. We haven't finished yet. We want to see if we can be able to factorize 3x squared minus 5xy minus 12y squared. And if we remember, that's what they tell us. We should do something like try and error to take 2 combination of values. So that's what we are doing here. 3x squared. The factor of 3x squared can be 3x and x. Now, that's what we said. Since the first term is 3x squared, the first term of the binomial factors must be 3x and x. Now, if it's 4x squared, then it can be 4x and x or 2x and x. So you see, we can try a lot of combination. 3x squared will give us only 3x and x. So this is more straightforward. Now, the product of the last term, which is negative 12y squared, which is given here, and the sum of the outer term and the inner term must be minus 5xy. And that's what we did here. So we have 3x before and x. Now, the product of 2 terms will give us 24y squared, will be 4y times negative and 3y. 4y and negative 3y. Remember the product, this is, sorry, I'm not using the 24y squared. We factorize negative 2 out. So we have negative 12y squared. So we can see that plus 4y minus 3y, which is the product, will give me, again, 12y squared. And then we, again, this is again try and error. So finally our answer will be 3x plus 4y, then x minus 3y. When we reach this stage, we have to check. So I will multiply all the terms here, and we should get 3x squared minus 5xy minus 12y squared. Because I can see here we have a plus 4y and x will give me 4xy. And also we have 4y and minus 3y. So that will give me minus 12y squared, which is this. Then next we have 3x and then minus 3y, which will give me 9xy. Now remember 9xy, negative 9xy plus 4xy will give me negative 5xy. So again, the concept here, as we saw the strategy, is try and error. So we'll see more examples. So let's see the next example, which is another method. We are going to factorize by grouping. So if I have 15x squared plus x minus 2, we can't do try and error here because 15xy squared is a lot of combinations. And also look at minus 2 we have here. So we can use minus 2 and minus 1. Again, this is a long process. So the best way we can do also, we can factorize this by grouping. So we can say, okay, A, it gives us 15, which is our first coefficient. B will be 1, and C is negative 2. So in this trinomial, we can say AC will give me minus 30. Again, this is trinomial by grouping. A is the first value, the second coefficient will be B, and the last coefficient will be C. So the first step is that we call this AC method. You multiply the first coefficient with the last constant value. So here we get minus 30. We now find the factors of minus 30. Whose sum is what? 1. Why is it 1? Because B is 1. Again, let me go through this one more time. We want to factorize 15x squared plus x minus 2. I always like to use this method when the first term, which is the x squared, is not 1, it's not 2, it's not 3. When it's 4 and more, if we are using the previous method, it will be too many combination try and error, and then we have to check the answer again, make sure it's correct. It's a long process. When the value is bigger than 3, I like to use the AC method, because the AC method, we don't need to waste time for try and error, checking the answer if it's correct or wrong. The first thing you do, they say we should factorize this trinomial. Take the first, which we call the A value, the coefficient, 15, times the last value, which is negative 2, C. That's why it's called AC method. 15 times negative 2 will give me 30. Now find the factors of 30, negative 30, that will give me 1. Why is it 1? Because B is 1. Now if B is 10, find two factors of, when you multiply A and C, find two factors that the result will give you 10. So here we say A is 15 again, C is negative 2, so AC will be negative 30 because 15 times negative 2. We now find the factors of negative 30 whose sum is B equal to 1 because B is 1. So such factors, of course, will be 6 and negative 5. 6 times negative 5 will give me negative 30. When I combine the two together, I'll get positive 1. The sum is B equal to 1. So we are good to go now. We are going to rewrite our expression as 15x squared. Now, instead of writing plus x, we are going to use those two factors, 6x minus 5x, which was the two factors we get 6 and negative 5. Then minus 2. Then we can group this together. So we group, and we see that 3 is common here, 3x, so 3x, 5x plus 2. Here, minus 1 is common between 5x and minus 2, so minus 1, we get 5x. So since we have 5x plus 2, 5x plus 2, our final answer will be 3x minus 1 times 5x plus 2. Now, if you like, you can multiply all the terms here. We should get the same thing as 15x squared plus x minus 2. So 5x times 3x will give me 15x. And then 5x times negative 1 will give me negative 5x. 2 times 3x will give me positive 6x. So positive 6x and negative 5x will give me positive x. Then 2 times negative 1 will give me negative 2. So one more, so that will be our solution. But one more, this is the best method. I always tell students, use this method instead of the first method, because here it's called the AC method. Take the first coefficient, which is A value, and the last coefficient, or the constant value. 15 times negative 2, multiply the 2, we get negative 30. Now look for two factors of negative 30 that when you combine or you sum it, you get positive 1 because b is 1. So we end up getting 6x and minus 5x. Then you factor by grouping. So I use these two terms here. 3x is common, left with 5x plus 2. Negative 5x and negative 2. I'll take negative 1 out. So automatically 5x become positive and negative 2 also become positive because we took negative 1 out. And that will be our final solution. So we can also factor the sum and difference of two cubes. There's a formula for this. So here we know s cubed plus y cubed is the same as s plus y times s squared minus sy plus y squared. If you multiply these two terms together, you get s cubed plus y cubed. And the same thing if we have s cubed minus y cubed is the same as s minus y, s squared plus sy plus y squared. Now when we start solving rational problems, expressions, we may use all these formulas. So now we know the form now. So if I have 27x to the power 6 plus 64y to the power 3, I can say, okay, there's no difference of 2 squared. Remember, difference of 2 squared means minus between. But with the cube, we have both minus and plus. So we can get, let's go back again. We can get s cubed minus y cubed. The formula is there. S cubed plus y cubed. The formula is there. So here, I'll find a way to convert the first term to cube. So luckily, we know 3 cubed is 27. Okay, so I take 3 out. And s squared cubed will give me x to the power 6. Okay, so this means 3s squared all cubed. 64 will be 4 cubed. 4 cubed is 64. So I'll get, and also y is y cubed. So I get 4y all cubed. So if I have this term now, I'll use the formula. The first term is 3s squared plus 4y multiplied by what? Square of the first term, which is 3s squared all squared, multiplied by 2 of the term together. So 3s squared times 4y. So we get 3s squared times 4y plus the square of 4y, so 4y squared. So finally, our answer will be 3s squared plus 4y, 9s to the power 4 minus 3 times 4 is 12. S squared times y will be s squared y. 4 squared is 16. Y squared is y squared. So we can see how we convert our question into sum of cube or cube sum. 27. For example, if this should be 12, we cannot use these techniques because there's no any value that when we cube, we get 12. Maybe 8 will be better. 8, 2 to the power 3 is 8. So we have to look at the value and the variables and make sure we can cube it to get that solution. So now we're going to solve some few problems to the end. So we know these strategies, difference of two squares in our previous lectures. S squared minus y squared is the same as s plus y times x minus y. We know the sum of two cubes, which we just did right now. S cubed plus y cubed is s plus y times s squared minus sy plus y squared. Difference of two cubes, x minus y times s squared plus sy plus y squared. So we're going to use this formula a lot, especially in geometry. In algebra. So here we say that if an expression has 3 terms, we always try to factor it as a trinomial. Now, if an expression has 4 or more terms, we can factor it by grouping. Then we continue to each individual factor is a prime. A prime means the only factors will be the number itself and 1. Always let's check the result by multiplying the answer we get to see if we're going to get the original question expression. So here we have some few terms here. I will use, as I said earlier, I will not use AC method here. That's to me too long. I'd rather use the try and error because the exponent is square, the highest exponent is square, which is good. And also the coefficient is 1. So solving this problem, first I'll factorize the x square, which will give me x and x, 2x is here. I'll find the two values. When I multiply, I'll get 12. When I combine, I'll get 7. So that will be 4 times 3 is 12. And the same 4 plus 3 is 7. Okay, then we finish. So we say by try and error, we find they are 3 and 4. The product is 12 and whose sum is 7, 3 and 4. So finally, we get s plus 3 and s plus 4. Now, if we multiply every term here, we should get s squared plus 7s plus 12. S times s is s squared. 3 times s is 3s. 4 times s is 4s. So 3s plus 4s is 7x. Then the last term is 3 times 4 is 12. So again, try and error. If the coefficient is 1, that is the fastest way. Find the factor of s squared, which will be s and x. Find two values. When you multiply, we get the last term. When we combine it, we get the coefficient of the second term. So let's try another question, the as squared plus bs plus c. We can try to find the numbers p, q, r, and s such that pq is a, rs is c, then ps plus qr is b. Again, this is called the AC method. First, I'm going to multiply a by c. Then I'll find a factor that when I combine them together, I'll get b. And that's what we are saying here, bs plus qr is b. Here, we are assuming the value should be at least 2 upgoing. Then this would be another good method to use. So we recognize this form, s squared minus 2s minus 3. What I'll do, I'll find the factor of s squared, which is x and x here. Look for two values. When you multiply, you get negative 3. When you combine, you get negative 2. So that would be positive 1 and negative 3. Negative 3 times positive 1 will give me negative 3. Negative 3 plus 1 will give me negative 2. So the answer will be x minus 3, s plus 1. Now, these are some of the special factorial formulas. Again, as I said earlier, we are going to use this formula a lot in college algebra, especially when we simplify polynomials or rational expressions. So this is the difference of two square. Again, a square minus b square is the same as a minus b times a plus b. A square plus 2ab plus b square, which we call the perfect square, will be a plus b all square. Then a square minus 2ab plus b square will give me a minus b all square. And a cube minus b cube is, since it's minus, we say a minus b. Then it will be a square plus ab plus b square. If it's a cube plus b cube, then it will be a plus b times a square minus ab plus b square. So let's see one example of difference of two square. So the question you have f4s squared minus 25. Oh, this question, we can't make it cube. But luckily, we can make it square. Why? Because we know 2 square is 4. 5 square is 25. So we can get 2x all square minus 5 square. So this is difference of two squares. So the answer will be 2x plus 5 multiplied by 2x minus 5. Now we have two questions here. We can see just by looking at the first question, 27s cubed. Okay, that would be 3 cubed. So 3s cubed minus 1 cubed. 1, any exponent you have with 1, the answer is always 1. So this will be 1 cubed. Same thing here, we have x to the power 6. So I can say, okay, this will be x squared cube, and 8 will be 2 cube. So this means I can use the cube formulas for the sum and the difference. So we can see the first one we have again, 27x cubed minus 1. So it's the same as 3x or cube minus 1 cube. So we get 3x minus 1, then 3x squared plus 3x times 1 plus 1 squared. So we multiply everything here, we get 9x squared plus 3x plus 1. And this will be our final solution. Same thing with the next one. This will be 6, so it's x squared to the power 3. 8 is 2 cubed. So we get x squared plus 2. Then we get x squared squared. So that's why x to the power 4. Minus 2 x squared, because we have 2 and x squared. Plus 2 squared, which is 4. So this again, a triperfect square, as we said earlier, is the same as a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. This will give you a minus b all squared. This will give you a plus b all squared. And now we have another question, 2x to the power 4 minus 8x squared. The first thing here, you can see that we cannot get square here because 2, if it's 4, that will be better. If it's 4, then we can say 2x squared or square. So the first thing I will do is to find the GCF, greatest common factor. 2 is common because we have 2 and 8, so 2 is F. Then s squared and s4, so s squared. So 2s squared, then the remaining will be s squared minus 4. Why? Because 2s to the power 4 divided by 2s squared will give me s squared. Then 8 divided by 2 is 4. S squared will cancel s squared. Then we can see that we have a difference of 2 squared in the parentheses. S squared minus 2 squared. So finally our answer will be 2s squared, s minus 2, s plus 2, because again, s squared minus 4 is the same as s squared minus 2 squared. So it's difference of 2 squared. So this is like factoring completely. First, find the GCF. If we cannot change the whole term to a cube or square, find the GCF. Then we look at the parentheses. Okay, this becomes a difference of 2 square. So we find the difference of 2 square. So another question, x to the power 5, y squared minus xy to the power 6. Here also the best way to solve this problem is to find the GCF, the common factor. The common factor, we have x here, x to the power 5, so only x. y2 and y6, so y2 will come out. So xy squared will be our common factor. Now if I divide s to the power 5 y squared by xy squared, it will remain only s to the power 4, because 5 minus 1 will give me 4. Y squared will cancel, then minus. Here also x and s will cancel, 6 minus 2 will give me 4. Again, we did the rules of exponent. When we are dividing, we subtract the exponents if the bases are the same. So this is what we get now. Now, when we look at this, we can see that it's like a difference of 2 squared, because we get s squared squared minus y squared squared. So the answer will be s squared plus y squared, then s squared minus y squared. Then we get another difference of 2 squared here again. So it will give us s plus y and y plus x also. I mean, s plus y, then s minus y. So our final answer will be our common factor, x, y squared. X squared plus y squared, we can't do anything, so we leave it. But x squared minus y squared is a difference of 2 squared again, so we get s plus y times s minus y. So that will be our final solution here. I think we have done a lot of example. Hopefully, again, by going through these video lectures, we will learn how to, again, factorize trinomials using both try and error method and also the AC method. Thank you.